They're very intense, and in fact, people have tried to figure out how much rain would have actually fallen during those thunderstorms. They're bigger than storms you see on the Earth, and they estimate that you could get about 100 or 120 centimeters of rainfall in a few hours in one of these Titan storms. So, when it's like, inches, that's, 40 inches of rain. Just think about, that much rain dropping in a few hours. It's definitely going to do something to the surface.
Yeah. I have a question. From what you've explained and what we've seen with the ground rocks and everything, could it become the equivalent of methane to sleep?
Oh, yeah, it's actually too warm on the surface for methane to freeze.
Oh, okay. I wasn't sure what the freezing point.
Yeah, the surface is about 90 Kelvin, and methane freezes around 80 or 84, something like that. But Titan's atmosphere is so thick that there's not very much temperature difference between the equator and the poles. If you got high up in the atmosphere, then you get cold enough that you might have methane snow, but before it hits the surface, it's going to melt and drop its rain. Yeah, that happens a lot around here, too. It's snow high in the atmosphere that drops its rain. It's probably happening tonight. So, in summary, this is what I love about this, is that we're finding new examples of Earth-like processes in completely bizarre environments. We have these streams on methane. We have this cold, faithful geyser on Enceladus, and we're trying to mesh those with our Earth experience and better understand, both what's going on in the Saturn system and also bring it back home to the Earth to understand what's going on here. And that's it. Thank you.
A couple of questions before we take a break. Anybody have any other questions? If not,
you've had a lot of great questions along the way, by the way. That's great. Yeah.
So we've exposed that our geologists don't really understand how stream beds form.
Yeah, well, we understand it, like in science we would say we understand it empirically, like we've observed it. We sort of see what happens in a place that's rainy versus a place that's dry. But if we wanted to write an equation that would describe it, we'd be very hard pressed. We have some, but they have these like fudge factors in them that you have to observe something, to do it. And we unfortunately can't do that on Titan.
Here
so
a miracle
we're trying to go back and do like the basic physics all over again.
Here a miracle happens. Okay,
yeah, exactly.
Fudge factor.
Some of the reading I was doing, they were saying that orbits of Uranus and Neptune are really affected by Saturn and Jupiter.
Oh, yeah.
And is the timing and the activity seen on the cracking, would that be within that time frame?
Yeah, actually, there's a big argument about that right now. You've stepped on one of the big landmines of planetary science right now. There's a group of a few scientists right now who are really starting to promote that theory that maybe that's what happened. If you run these models of how the planets in the solar system have orbited over time, it turns out our solar system the planets haven't always been in exactly the same orbits since the beginning. They migrate over time slightly. And one of the things that happens is that Jupiter has actually migrated out a little bit, and sometime in the last billion years, there are not all models predict this, but some models predict that sometime in the last billion years, Jupiter and Saturn would have gone through this resonance, where Jupiter's orbit would have started affecting Saturn's orbit, and it could have changed, the relationship between, could have changed basically the stability of the orbits of all of Saturn's satellites, and that. So the idea is that maybe this, faraway influence, Jupiter, could have actually somehow changed the Saturnian system enough that you reshuffled the satellites. Some of them crashed into Saturn. Some of them got really close and smeared out into a ring. And the other ones experienced a lot of tidal flexing, as they sort of settled into new orbits that would have created a lot of heat and generated a lot of new activity. The reason why everybody hasn't totally jumped on this as the obvious explanation for anything is that there are some very well-respected orbital modeling people who say it's a bunch of bunk and their models don't do it. And there's two guys who have a model that does it. And Yeah, the people who don't do models like me are sort of waiting for them to fight it out. See who's right. So. Yeah.
Do we know enough about the dynamics on the surface to figure out what the eventual fate of the Huygens probe will be? Like,
oh, yeah.
Will it wash away, or will it just remain on the surface for a very long time?
One of the things I'm trying to figure out with this research on streams is trying to figure out how active this process is. Like, we saw all this sort of gravel around the Huygens probe, but has that been there for a long time, or is it constantly being covered with gravel like every year when a new rainstorm comes through? And we're very far from knowing the rate of that yet. As far as the all the instruments and stuff on Huygens, it's pretty cold there, and there's nothing too corrosive on the surface that we know about, so it should be fairly well preserved for a long time.
But it's most likely going to remain visible on the surface for quite a long time.
Yeah, I'm sure. It's not that big, so good luck finding it. But actually, its parachute might be easier to spot. The way that the probe landed, its camera was actually facing the opposite direction from where they think the parachute landed, so they didn't get a picture of the parachute lying on the surface. But but you should see this. It's maybe about this big around, and then it has and then it'll have a cord and parachute sort of streaming downwind somewhere. And it's possible that maybe maybe the winds will pick up someday and sort of drag it across the surface. Pick up the parachute and drag it.
Yeah, cool.
It was. Oh, sorry. Just to finish my thought. It was powered by a battery actually, and so the electricity ran out in just a few hours after it hit the surface. And so there's nothing that is going to keep any of the instruments alive. It's going to cool off. It was warmer than the surface while the instruments were going because the electronics were sort of creating some heat. And some people worried that maybe it might have melted some of the ice around it, and you'd have this sort of any earth bacteria that might have been on the Huygens probe could have actually gotten into some liquid water and we've contaminated Titan. But it would have frozen very, very quickly after that. Unlike, say, if we sent a probe that had a radioactive generator, then that could have kept something warm for a long, long time. So we worry about sending long-term probes to Titan and what the impact of that would be on contaminating Titan's surface. Sorry, you had a question.
Oh, I was just wondering if there was any storms going on right here. With clouds.
Oh, any storms in that area? Yeah, no, we haven't spotted any there yet.
I mean the whole planet itself. The whole moon.
Oh yeah, we've seen a lot of storms near the poles, but we've only observed Titan for about. Its seasonal cycle is a lot longer than the Earth because it depends on Saturn's orbit. So it basically, completes one full round of the seasons during one Saturn year. So we've only observed it for about the equivalent of 2 or 2.5 Earth months. So we don't know whether right now it's southern summer and northern winter on Titan, and it's going into northern spring right now. And so we don't know whether the storms that we're seeing near the pole are just a spring phenomenon, or is that how weather always works there? Or maybe if we go into the spring and into the summer, maybe we'll see lots of storms around the equator. We don't know enough about Titan's weather yet and how it responds to the seasons.
Okay, I guess we're going to take a break for a while now. If you have other questions,
yeah.
We'll for a little while.
Lots of cookies. We'll reconvene in about 15 minutes.